What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we will be looking at part 4 of our Pandas tutorial series in Python. So without any further ado, let's get to it. So I did mention in the previous video, right, that this video introduces us to this concept called a data frame, this concept or object called a data frame. So just to talk a bit about this, right, you see, a data frame is basically a rectangular table of data, and it collects or contains rather it contains an ordered collection of columns. So just like how you have a spreadsheet, guys, that's exactly what a data frame is. It has rows, so comma, it has columns, comma. A data frame has rows, it has columns, contains data. Now, given the fact that it has columns, columns have, or let's say can contain, different data types. Okay, that's a very important point to note, that we are not limited to storing a fixed type of information in the data frame. The data frame is very versatile. You know, in one column you can store integers, in another you can store strings, in another you can store booleans, and so on. So it gives us a lot of flexibility and it gives us a lot of versatility. Now, I want you to think of a data frame. So you guys know what a series is, right? We know for a fact what a series is. To run the previous script, this is a series. This here is a one-dimensional kind of table, and it's a series. Okay, now a data frame, think of a data frame as having multiple series that are joined together. Okay, and it gives you this lengthy table going from left to right. That's exactly what a data frame is. It's multiple series, one-dimensional arrays. We're focusing on this here, the n column. Okay, this column of data here, multiple of these placed side by side gives rise to a data frame. And think about it, in the data frame, instead of just having a fixed kind of data type to all columns, one column could be integers, another can be strings, and so on. So that's the flexibility of a data frame. So this is us talking about it before you actually view it, right? It's always a good idea and practice to talk about stuff, and then when you implement it, it makes a lot more sense after that. So just to share a bit of factual information to you, if you are going to work with data structures and algorithms module in your Python journey, you will often encounter this data structure called a dictionary. Now, it's good to understand that the dictionary itself, okay, this is what enables. So I will add this as a comment: enables data frames to store information. Okay, data frames store information under the hood as a dictionary. Okay, it's some sort of collection. So that's fine. We are not going to go into the in-depth of discussing how the data frame works under the hood. That's out of the scope of this lecture. I just want to bring it to your attention that the dictionary itself is what enables a data frame to store information. So there's several ways to construct a data frame. One of the most common ways, as you guessed, is using a dictionary in Python. So let's get to it. I will, first things first, I'll import pandas as PD. Next, I will set up a object. I'll call it data. Let's say this is a dictionary. So what I'm going to do now is I am going to kind of create this dictionary. This dictionary will have three keys: state, year, population, and the values will be appropriate lists, okay, for those keys. So let me create this now. I will say for the first key, this can be state. Now the state key will have the values. Let's do Ohio. Let's do Ohio. Let's do Ohio. Let's do Nevada. and again Nevada and Nevada. So that's the state. Now I need or want to have two more keys. So I said state, I will have year. We'll keep this simple again. Let's just do maybe 2000, 2001, 2002, 2003, or let's do again, let's replicate a few of the years. So 2000, 2001, 2002. Now we'll do 2001 comma 2002 comma 2003. And I should mention to you guys that this is just me creating dummy data. You guys are free to use any values that you like, okay, to the respective keys. So yeah, you guys can go ahead, play around with that. Now let's do population. So let's do 1.5, let's do 1.7, maybe we'll go for 3.6. Yeah, 3.6. I'll do 2.4, I'll do 2.9, and I will do, last but not least, 3.2. Now you may ask, why do you have 6 values here? Now the question to that is simple. It's because for data frame, right, the values become the rows. So if I have inconsistent rows across my keys, that itself is going to be a problem. I need to ensure that the values across all keys are consistent in terms of number of values that exist. So as you'll see, the state key has 6 values. Year, it's also the same. There are 6 values. Population, it's the same, 6 values. Now, what you're going to notice, all right? So first things first, let me just create a variable here. Call this data frame. Keep things simple for us. pd.data_frame. Please pay careful attention, guys, to how the method data frame is being called. The D and the F need to be capitalized. So within this we pass data, so data. As you can see, the argument or the parameter is data. As you can see, Spider gives us that autocomplete. So the parameter we are interested in is data is equals to, by default it's set to none. So if you call this data frame method with an empty parenthesis, what it will give you, if you are wondering, is an empty data frame. Okay, the same will happen with the series method. If you call dot series without passing any values or arguments, you'll get returned an empty series, so an empty table. Okay, now we want a data parameter to be set equals to data, so there's no point saying data is equals to data. I will just pass data, which is this dictionary here. Now when I run this, what you're going to see is that the keys of the dictionary become the names of the columns. As I told you, the values of the dictionary becomes the appropriate rows in the columns themselves. So control enter, and as you can see, this is what we obtain. By default, again, in the data frame object, we have an indexer column that is added by default, which makes it easy for us to query the data frame. So it's like working with an SQL database, okay? Think of it as that. You have this table, you have different methods to be able to query it and access the information within. So what I'd like to show you now is, you see, oftentimes in Python, we do tend to work with large data frames, and it is for this reason that we have a method that is able to be called on a data frame. It is called the dot head method. Okay, as you can see, the head method will return the first n rows. By default, it is defaulted to 5, a value of 5. So int is equals to 5. Actually, n is equals to 5. So as you can see, by calling the head method on a data frame object, I get returned with the first n rows. It is defaulted to 5. We have 6 rows in our data frame. So if I want to have all 6 rows, what I can do is, so as you can see, this is data frame dot head. There are 5 rows that are being shown to us, 0 to 4. Now if I pass 7 here, we don't have 7 rows in the data frame, so logically speaking we have 6, so I get returned with all of the rows in the data frame. So if I do 6 As you can see, that's all the rows in the data frame 0 to 5. Okay, so that is good. Let me actually leave this here. I'll comment that out. Now, that is fine. Now, what I'd like to also show you, right? This is the power of data frames and Python and Pandas itself. Now, pd dot data frame data, as you guys can see, right, this is the current data frame we have state here, population. Now if I want to restructure the columns themselves, what I do is columns is equals to, and I just pass the respective order in which I want the columns to show up. So year, state, pop. At the moment we have state, year, population. I want it in year, state, population. So we're swapping state and year. Okay. Now what you'll notice is when I run this, that's exactly what happens. Year, state, population. Now, if we view the original data frame object, so see, this is not year, state, population. This is state, year, population. The original data frame did not change. If you want the original data frame to change, you're gonna have to create a new object. So data frame is equals to, and then you'll do it manually, pd dot data frame, and so on. You get the point, guys. So data columns is equals to, so I'm silly, I should have copy pasted that, but it's fine. And last but not least, population. Now when I run this, what you're going to see is that now the data frame has its order changed. Year, state, population. Before it was state, year, population. So that's a good thing to keep in mind. Okay, the order in which you actually do your manipulations. So that's fine. Now what I'd also like to show you is that, let me show you this, right? So I'll comment that out. I will say data frame 2 is equals to pd dot data frame, and within this I am passing data. I will say columns is equals to year, state, population, and depth. So here in the columns portion, we have the data we are working with, right? The data is that default dictionary we defined up here. Now we have a new column that's showing up in the order of the columns. That column is det. Now this is important. Basically what we are trying to do is implicitly, we are trying to implicitly slash explicitly create a new column in the data frame, a column that did not exist. There's no data for the rows of the column, but we want to have the column show up in the data frame itself. So that's something to keep in mind there, guys. Now what I'd like to do is, this is something we learned in the series aspect of the work, that keyword argument called index, and we can manually provide an index for each row. We have 6 rows that we are working with because data is being drawn from this dictionary here, and according to the number of kind of elements in the values, we have 6. So let's do 1, 2, 3, 4, 5, 6. So I actually spell, my way of spelling 6 is SIEX, but don't judge me, guys. Anyway, moving on. So this is what we have now, right? This is important now because when we run this code and when you print the actual contents of data frame 2, what you are going to observe is very interesting. Okay, it's the default way in which pandas data frames behave, especially when a new column has been declared and stated, but there's no data for the column that has been provided. So control enter. I see I have made a mistake here, so let me correct that. What is the issue? Positional argument follows keyword argument. Okay, so there is nothing to stress about here. What I just have to do is data is equals to data. Okay, no, guys, that's actually I actually forgot to include a list here. My bad. So that is sorted out now. Now, when I run the script, so what you guys are going to observe, a data frame that is being constructed with 3 columns, but in the columns parameter, we have a 4th column that has been declared called det. There's no information or values that are, or data that has been provided to populate the det column. So what we are going to observe is as follows. Pay attention to this, guys. We have year, state, population, and debt. So as you guys can see, I actually made a slight error here, but again, you are witnessing pure pandas data frame behavior. Now the mistake I made is that when I pass the order of the names, I am using the data from this dictionary, right? This dictionary does not have a key called population. It is called pop. So when I call the order of the columns, I called it population, and automatically in the dictionary of data, Pandas did not find any key with the name of population, and so it assumed that I want a completely new column, and by default behavior it populates it with NaN values, as you can see as well for the det column that we created. So to fix this, I'll just take out the ulation part of population. So this is what we observe. The most important thing for you to take away from this is that when you are creating new columns for a data frame, you'll have the ability to do it using the columns argument or parameter itself, and you can just provide your columns in the list itself. Okay, pandas will take care of the rest. It will populate that column with NaN values. We spoke about NaN values. NaN is the equivalent of null or missing values, which makes sense because we don't have values for the det column. So that is all interesting stuff. Now, one thing I'd like to show you now again is how you have the ability to retrieve columns from a data frame. So what you can do is the name of the data frame in square brackets. Then what you'll do is pass the name of the column that you'd like to retrieve. So let's do state. So as you can see, guys, we will do print data frame 2 dot, or rather in inverted commas, within square brackets, the name of the column. So print data frame 2 state. When I run this, we obtain the entire state column from the data frame. Now this word state comes from the header row. This is the header row, tells us the names of the columns themselves. Okay, now you have another option. This all stems down to preference and what's easier and more convenient for you. Instead of using square brackets, you can use dot notation and the name of the column itself. So data frame dot state, and output will be the same. Okay, you can do this for any column that you like. The choice is up to you. And preference, the most important thing is preference. That is entirely up to you, whether you'd like to do it using square brackets or dot notation. So let's do DEBT and we'll obtain, okay, so data frame object has no column det. Did I make a mistake here? Let me go through this, guys. Okay, yeah, I did. So instead of data frame 2, I actually used data frame 1. That is silly, but yeah, you get the idea, guys. This is what we have. So choice is yours. Dot notation or square bracket notation, you choose. Now, we have done quite a bit of interesting stuff for this video. I am going to end the video here. In the next video, I will talk more about the concept of indexing and returning values comma columns from the data frame. So all this stems down to querying the data frame. So we did well, guys, in this video. With that, I will end the video here. Thanks for your time. Thank you so much for watching the video. Good luck with your work, and I will see you in the next YouTube video.